Good day and good day and welcome everybody at the fourth Sustainability Conference at the University of Akureyri. It was great for me to see and learn presentations from other speakers, and I personally would be giving you some insights about how long is until we are going to be proud of our local Icelandic fisheries being emission-free. And as Sean has mentioned, my name is Stanislav. I'm a naval architect from a local ship design and marine engineering company dealing with designing of fishing and scientific research vessels. And this presentation was prepared together with our industrial partners named Clara Arctic Energy from Reykjavik, who are responsible for introduction and promotion of green technologies for Icelandic industry. And our friends from Clara Arctic Energy actually asked me to give you a message that the topic we are going to go into is kind of a complete jungle. So with this slide, I'm giving you this message, but I'm also trying to ensure you that we will approach it in structured way, with going from part of understanding the basics of emissions and regulations into getting to know about available technologies and how are they applied to reduce energy demands. And we will sum up things with some ultimate emission elimination options and try to apply them and forecast things for Iceland. So the main problem that we are having nowadays is still more or less the same as it was at the beginning of era of combustion engines. The most of maritime industry is still dependent on those combustion engines which are working on fossil fuel technologies. Okay, maybe now the fumes and exhausts are not so black and dirty, but the chemical components are still the same, among which the most dangerous, which we are going to talk about, are CO2, nitrogen oxides, sulfur oxides, and particulate matters. Hopefully, there is an international organization, which is called International Maritime Organization, acting on behalf of United Nations, which are protecting us through different regulations, studies, and researches with a goal to conserve and sustainably use the oceans and make everything good about that. In Iceland, Icelandic Transport Authority and Icelandic Environmental Agency is responsible for implementing the things which are coming from International Maritime Organization. And one of the form of actions from IMO is that IMO makes conventions based on research. And in those conventions, there are regulations. And our particular focus today is on a convention called MARPOL, Annex 6 of which is dealing exactly with dangerous air emissions from on board the vessels. And it talks about regulating them, recommending what to do, making the limits, and so on. It also, the main thing that it talks about different emission types. We are not going to focus on some specific equipment emissions or some specific type of vessels which produce some specific emissions. The interesting thing is also that a very well-known CO2 is completely not, almost completely not applicable to fishing vessels today, except some operational documents. The most focus is brought into nitrogen oxides, sulfur oxide, and particulate matters. So why this happens? Why so very much hyped CO2 is not targeted? And should we do it? Let's try to answer this question. Let's try to look at the picture in general, and especially for Iceland. If you will look at the total emission figures, you will under human-made artificial emission figures for CO2, you can understand that Iceland in global scale makes 40 times less effect than even Bitcoin mining. Of course, everybody here would be happy to hear that on per capita level, we are as usual on the first place. But if we will further go to maritime industry, you can see this pie chart and see that all the maritime industry, which called shipping here, commits only 3% of the total artificial sources. And fishing industry is a part of these 3%. In addition, it's good to know, according to the researches conducted, that Icelandic fisheries are particularly good. So Icelandic cod is better than Norwegian cod, for example. So we can be happy about that and move, at least for now, and move to other emission sources, which doesn't have such a cloudless picture. So nitrogen oxides, sulfur oxide, and particulate matters, they have a much higher percentage coming from maritime sources. And according to some of the researchers, the share distributions between land-based and maritime-based sources could even change with having more coming from ships. Moreover, why maybe CO2 is not treated so much in at least for fishing vessels? You can see this terribly big amount of totally artificially emitted CO2, which is 41 gigatons in 2021. And you can see just 3 gigatons of nitrogen, N2O. But according to the respectful researchers, the impact on greenhouse effect from N2O is 265 times higher than of the same amount of CO2. So then even with the fact that you emit just 3 gigatons, the effect is 20 times more than CO2. And having in mind this percentage, that's what we have to treat. And that's what IMO is dealing with presenting regulations globally and for some specific areas, regulations for sulfur oxides and for nitrogen oxides. And here you can sleep quite well because these emissions are treated and constantly reduced, and most of the tonnage of most of the fishing vessels, countries representing most of the vessels in the world, accepted this. So the future looks bright, but we want to be completely emission-free. And there are technologies. There are technologies for helping us to reach these levels nowadays and further on. And those technologies could be divided into 3 different directions. First, it's some kind of technical upgrades, a piece of equipment that you put and it cleans your exhausts, for example. The other option is you optimize your performance, you optimize your design, you optimize your energy management and your operations. And the third direction is when you introduce some alternative sources of energy or alternative fuels. Some of those items are applicable to fishing vessels, some not, some are rational, reasonable, some are not feasible or economically not interesting. When we do our designs, we try to use everything what is reasonably good for our customers. Fishing ship owners are also quite practical guys, and they would not gonna pay for something which is not fully proven and which is not obligatory or not giving them direct benefits. So you have to have this specific thing in mind. But nevertheless, if you want to optimize something, you should understand the benchmark, the foundation. What are you going to optimize? And we are optimizing with those different measures the energy demand and the amount of emissions. So to do it, we need to understand first how much energy does our vessel need. So in this case study here, we are talking about some freezer trawler of around 60 meters. And for understanding how much energy is needed, we first divide its operation within a fishing trip, a fishing voyage, into different stages. Quite easy for us. Then we know all the equipment consumers. We know how do they work during different stages of operations of a fishing vessel. And by combining all these with quite a simple formula, we are getting a total energy demand in amount of kilowatts per hour. Then with this case study and more than 2 million kilowatt hours needed, we further transform it into tons of fuel needed, and we can easily calculate for the technologies, for the used technologies, we can easily calculate how much emissions would be emitted. So here is an example with CO2, and for this amount of fuel, which would be spent by this vessel just during one voyage, this huge amount of CO2 is emitted. And here we are coming to our design algorithm. So we start with 100%. We have these values. Then we apply the possible measures which we discussed on previous slides. We reduce the energy demand and we reduce emissions on 50% from design optimizations, on 5% from technical upgrades, and so on and so on. So at the end, we are happy to say that we achieved almost 28% reduction in energy demand and related reduction in different emissions. Then we are asking ourselves, are we happy? As for today, we say, yes, it's a great achievement. We will market our vessel. If you will buy our design, your code would be better than Norwegian code. But if we will speak about the future, the answer would probably be no, because this is just our new 100%, and the value of emissions are still big and they have to be eliminated. So then we are coming to ultimate emission elimination options. And for some specific types of emissions, there could be some very efficient technical upgrades. Or it's better even to think about alternative fuels. And IMO also realized that. And IMO made a goal for the maritime industry to become completely carbon-free or almost emission-free until 2050. And IMO also says that most probably this would be hard or impossible to achieve unless we will adopt alternative carbon neutral fuels. Because now we are in this area, look how many carbs all those bad fuels are having. And we need to come here with carbon-free or almost carbon-free solutions. And speaking about fishing vessels, the most applicable for this case would be hydrogen, ammonia, and methanol fuels. As you can see from this slide, they're not giving us the turnkey solution which will save everything and reduce all the emissions. Yes, in most cases, CO2 and sulfur oxides are reduced. In case of methanol, we should get help from our colleagues from other industry to make e-methanol by reusing CO2. In nitrogen oxides, there are different additional measures to be done to make things being close to 100% reduction. But then there are also important complications we have to have in mind. Those fuels are produced with usage of energy. So if energy is coming from fossil fuels, then it's not green solution, speaking about the total life cycle picture. So we have to come to renewable energy for production of these things. Then we are coming to complications like, for example, for ammonia, the heavy toxicity, the technologies that in some cases have to be yet developed. And with all this knowledge, we're coming to Icelandic fleet, which could be divided in vessels of different sizes. And you can see different quantities. And with having knowledge how to calculate energy demand, we are doing this and identifying what options are possible for different vessels of Icelandic fleet. And here are the solutions, the possible solutions that we're thinking about. That for small-scale fisheries and also for touristic industry, because the energy demand is more or less similar, the best would be to introduce hydrogen fuel cells options or to run things on batteries with charging them from renewable sources, Icelandic energy sources. Future solution would be hydrogen, which has the tendency to become cheaper in comparison to batteries and is more kind of true zero emission solution. Battery is something which is more available nowadays, but the costs are high and the technologies are still to be more developed. So when we talk about question when these type of vessels in Iceland would become green, my answer would be something like pay and play. If you are able to pay, the technologies are available nowadays. If you want, install, but you will have some difficulties with your operations. How much money is needed? Please don't treat these speculations seriously. Just having some knowledge how much a vessel costs, I increased this value and multiplied it on every to get that you understand how much would be needed to completely renew 600 tiny vessels and 850 bigger vessels, vice versa. So you need some and do suitable infrastructure. We are talking about something like 10 billion. When we come to bigger vessels, the hydrogen and battery solutions are not applicable. We need to do methanol and ammonia options. Methanol is more readily available. Ammonia is very toxic, and you need to build an ammonia plant and ammonia storage facility in the middle of the port. But the problem in Iceland that most of the cities are built around the ports. So some regulations have to be finalized. Some support have to be done, infrastructure have to be achieved. And if we will play the same silly game for just getting some brief understanding, how much money would be needed on average for turn all the big vessels green, you will need approximately a bit more than 3 billion. For making infrastructure, which is a bit more complicated because you need to put it all around Iceland for big vessels to be charged properly, you need also some amount of money. I took this value out of nothing, approximately, just to say to you that, let's say, around 16 billion euros are needed. In comparison to Icelandic GDP, you can do that. You can also compare it to net worth of some richest people all around the world, and you can understand that if you want, it could be done tomorrow. But you have to have in mind the one of the biggest limitation which we haven't solved. This limitation is that if you have marine diesel oil, you need, let's say, 500 cubic meters of fuel for this type of vessel. And 1,000 cubic meters will be used for cargo. You will earn money with these 1,000 cubic meters. While if you will look at ammonia, it has 3 times less package factor, meaning that you need to have 3 times more amount of space used for your ammonia, which means that for our vessel, you will have no cargo unless you wouldn't change the design thinking, you wouldn't do proper research and so on. So even if Elon Musk would come to you tomorrow and spend 16 billion euros on making the whole Icelandic industry green, in the current state, that will make maybe no good change, because you understand why. Still, we have to address the threats. We have to address health issues. We have to address negative artificial-driven climate change. And we have to make this move in future because carbon, fossil fuels are going to run out. So if you want to continue living at the same and increasing standards of living, you have to go green by this or other reason. And to do that, on international level, there are different drivers of changes. They are supporting nationally and internationally. Norwegians are giving the best example with subsidizing 80% of all additional costs from introducing innovative technologies. Or their other driver of change is regulations and taxes. European Union usually applies stricter law, and Iceland usually follows. So we have to make sure that proper amount of researches and innovations are tested and done, and decisions are made on national level in Iceland, so that when a more strict tax would come, it would be not too short notice for making the changes. And maybe for now, for this topic, the least influence is coming from public opinion and actions, because everybody is talking about some other more fruitful things. So with this presentation and with participating in today's event, my idea was just to introduce you more into this topic. Maybe it will help to bring more actions to the field, and together, by this or other reason, we will make our future a bit more cloudless. So thank you very much for giving me a chance to present. I also didn't mention one thing about going back to the past with introducing wind technologies. This is a completely separate stream of research. And here are some examples of our vessels. But this is a separate topic. I'm not going to stop for today. So thank you. And with this, my presentation